In a bold and remarkable breakthrough, scientists have announced the discovery of a celestial body that challenges what we thought we knew about the solar system. NASA, the agency behind some of humanity's greatest achievements, has once again captured global attention. This time, the focus is on a small world quietly orbiting between Mars and Jupiter, a world that has begun to glow with unexpected light. At first glance, Ceres seemed like a typical rocky body drifting in the asteroid belt. But images revealed something extraordinary, glowing bright spots scattered across its cratered surface. The discovery set off a wave of curiosity. Were these patches made of ice or salts? Or could they represent something entirely new in planetary science? A few bold theories even proposed that the lights might be artificial, though most scientists remained focused on finding a natural explanation. The mysterious object in question is Ceres, the largest body in the asteroid belt and the first dwarf planet ever discovered. Although it lies relatively close on a cosmic scale, the secrets hidden beneath its surface could reach far beyond our solar system. To uncover those secrets, NASA launched the Dawn spacecraft in 2007, a mission designed to explore two of the largest worlds in the asteroid belt, Vesta and Ceres. Powered by revolutionary ion propulsion, Dawn was capable of gently adjusting its course and visiting multiple targets, a first in the history of spaceflight. Its journey began at Vesta, where it spent over a year orbiting and studying the asteroid's rugged surface. The data revealed a record of ancient collisions and the building blocks of early planetary formation. After completing that phase, Dawn departed for its ultimate destination, Ceres. Ceres itself has a unique history. It was discovered in 1801 by the Italian astronomer Giuseppe Piazzi, who believed he had found a new planet. But with the discovery of other similar objects, Ceres was soon reclassified as an asteroid, and for more than a century, it faded into obscurity. Then, in 2006, the same year Pluto was redefined, Ceres was elevated to dwarf planet status, the only one located in the inner solar system. By early 2015, Dawn finally arrived at its target. As it drew near, the first images revealed something astonishing. A series of brilliant white spots shining from within the dark craters. The most striking of these lay inside a Cater crater, a basin nearly 92 kilometers wide. Against the muted gray surface, these reflective patches glimmered like beacons. Scientists were stunned. Could this be exposed ice? Crystalline salt? Or signs of ongoing geological activity beneath the surface? Public fascination grew rapidly. For the first time, the world was looking closely at Ceres, a world once dismissed as inert and lifeless. To scientists, these glowing regions were not just visually captivating. They were a puzzle that might hold clues to water, internal heat, and even the chemistry needed for life. As Dawn continued to observe, its instruments began to reveal a complex, evolving picture, one that would soon transform our understanding of this small but remarkable world. Secrets beneath the surface. As higher resolution images arrived, scientists began to see the truth behind these dazzling spots. They were not isolated patches, but clusters of highly reflective material, spread across the crater floor and its ridges. After extensive analysis, researchers concluded that the bright regions were primarily composed of sodium carbonate, a type of salt formed when briny water slowly evaporates in the vacuum of space. This process, known as cryovolcanism, is unlike the volcanic activity seen on Earth. Instead of molten rock and lava, cryovolcanoes release liquid water, ammonia, and other volatiles, which quickly freeze or sublimate upon reaching the surface. When the water vapor escapes, what remains are brilliant salt deposits, the shining lights that first caught the attention of the world. Even more astonishing was the evidence that Ceres might still be geologically active. Transient hazes, observed within a Cater crater, suggested ongoing sublimation, possibly indicating that subsurface water was still escaping to the surface today. This discovery transformed Ceres from a silent, frozen world into a potentially dynamic planetary body. Scientists believe that beneath its crust, Ceres contains a vast reservoir of water ice and briny liquid, mixed with rocky materials and clays. Its outer layer is porous and relatively soft, while deeper inside lies a mantle rich in frozen brine and hydrated minerals. The heat required to maintain these underground pockets of liquid likely comes from the radioactive decay of isotopes within Ceres' interior, a slow but constant source of warmth over billions of years. This internal heat may have kept portions of the dwarf planet's subsurface liquid for extended periods, allowing salts and minerals to rise through cracks to the surface. Adding to the intrigue, Dawn detected ammonia-bearing clays on Ceres, compounds rarely found in objects that formed near the Sun. This hints that Ceres may have originated farther out in the solar system, possibly near the region of the giant planets, before migrating inward. The presence of ammonia is critical because it lowers the freezing point of water, making it easier for liquid brines to exist beneath the surface. Such an environment, cold, salty, and potentially stable for eons, raises exciting possibilities about microbial life. If liquid water and organic materials once interacted below Ceres' crust, life might have emerged there in primitive microscopic forms. Even if life never took hold, Ceres still offers an invaluable glimpse into the processes that shaped the early solar system. Because it has remained relatively unchanged for over 4 billion years, Ceres acts as a cosmic time capsule, preserving materials that date back to the dawn of planetary formation. The Dawn mission revealed a landscape rich in variety, craters, ridges, domes, and fractures. Each feature a chapter in Ceres' complex geological history. Among these, the Ahuna Mons volcano stands out, a towering cryovolcanic dome formed by repeated eruptions of salty slush slowly accumulating over time. Such evidence strengthens the case for long-term internal activity and ongoing geological change. Even after Dawn's mission ended in 2018, the data it returned continues to reshape scientific understanding. It challenged long-held assumptions about where water and geological energy can exist in the solar system. Ceres has proven that even small, cold worlds can be surprisingly active, harboring environments where the building blocks of life may persist. The bright lights that once seemed like distant mysteries are now known to be vital scientific clues, markers of chemical evolution, and perhaps precursors to biology itself. Though Dawn fell silent years ago, its legacy endures, reminding us that every discovery draws us closer to answering one of humanity's oldest questions. Are we alone in the universe?